Good morning, everyone. Today we'll be diving to the world of MongoDB, a modern NoSQL database that is designed for scalability, flexibility, and high performance. So, this presentation is part of our ISM 6217 database management system course, and my name is Tulasi Valluru, and I'll walk you through MongoDB's journey, features, and where it fits in the database ecosystem. So let's begin with how MongoDB came into existence and its visual identity. This slide shows the logo picture and the launch year. MongoDB was launched in 2009 by a company called Tengen, which later became MongoDB Inc. The founders were Dwight Merriman, Elliot Horowitz, and Kevin Ryan created it in response to the limitations of relational databases when building large scale and dynamic web applications. And the logo always includes a leaf icon alongside the company name. It is available in four color variations. You can choose the one of that provides the best contrast with your background. Now that we know how MongoDB have started, and let's talk its early growth and company's background. The name MongoDB is derived from humongous, reflecting its vision to handle vast amount of unstructured data with speed and ease. The database quickly gained popularity in the developer community, and by 2013 the company rebranded as MongoDB Inc. In 2017 it went into public on NASDAQ under the ticket symbol MDB. Since its inception, MongoDB has grown from niche database to the global leader in the NoSQL space. Initially, it is designed for web scale applications. It now powers everything from startups to Fortune 500 companies. The company embraced open source principles which helped it gain adoption quickly. Over the time, it evolved into a full fledged data platform with advanced features like MongoDB Atlas, it's a cloud solution, and robust security and analytics capabilities and integrations with modern DevOps pipelines. Today, MongoDB is used in mission critical applications across all the domains from retail to healthcare and to IoT. So, let's explore the kinds of customers, the industries that benefit from using MongoDB. So, this slide highlights how MongoDB is adopted across several key industries, each leveraging its flexibility in different ways. In retail and e commerce, companies like eBay and Sephora use MongoDB for product catalogs, personalized shopping experience, and inventory systems. And in financing and banking, Barclays and Coinbase use it for customer analytics, fraud detection, and building scalable API services. Healthcare and the healthcare organizations such as Pfizer and OneUp Health use MongoDB to manage patient records, research data, and clinical trials. In gaming, the companies like EA Games tracks the player stats, session data, and the leaderboard information in the real time. IoT and smart device firms like Bosch and Siemens use MongoDB for device telemetry and connected home platforms, which require scalable and schema flexible storage. Lastly, the telecom and media use the companies like Verizon and Adobe use MongoDB for tracking user behavior and managing content metadata and analyzing streaming activity. MongoDB's adaptability across all these domains shows its strengths in handling large volumes of semi structured data, especially when performance and scalability are critical. So, to understand why MongoDB is so versatile, let's define what kind of database it is actually. So, MongoDB is a distributed, document oriented, operational, NoSQL database. It is distributed, meaning it can run on a cluster of machines for scalability and fault tolerance. It is document based, means storing data in flexible JSON like structures called bson. As a operational database, it is optimized for real time transactions and application backends. It supports both on premises and cloud native developments, offering commercial support through MongoDB INC. Its distributed nature allows its horizontal scaling, which is difficult and expensive with traditional database. And the commercial product offers enterprise license and the support. And it is user and focused. It is designed for app developers and the teams. And this is not centralized. It is decentralized by design, non single point architecture. So let's now contrast MongoDB's non relational structure with traditional relational models. So the traditional relational database like MySQL or Oracle use a rigid schema with rows and columns, which makes it difficult to adapt as applications evolve. MongoDB, on the other hand, it is non-relational. It uses documents instead of tables. These documents are self-contained and can contain arrays and nested fields. This eliminates the need for complex joins and allows embedding of related data directly in one object. This model aligns well with how modern applications, especially those built with microservices or agile methodologies, handle the structured data. So, where does MongoDB live in your server room or in the cloud? Let's talk about the accessibility. So, MongoDB offers two major modes of deployment. One is in house, and the other one is cloud. In house, you can install and run MongoDB on your own infrastructure, giving full control over configurations, backups, and security. The cloud based is MongoDB Atlas, a managed service that runs MongoDB clusters on AWS, Azure, or Google Cloud. Atlas handles backups, scalings, monitoring, and even integrates with BI and visual tools. For developers, the cloud option reduces maintenance overhead and accelerates development time. So let's move on to the pricing. How much does this flexibility cost? MongoDB's pricing model is quite flexible. The community edition is open source and free for everyone to use. MongoDB Atlas offers a free tier cloud cluster, perfect for learning and small apps. Paid plans are based on storage, performance needs, and additional features like backup security. And enterprise plans offers SLAs, advanced toolings, and on perm deployment options. This makes MongoDB more accessible for everyone from students to startups to massive enterprise teams. So now let us explore MongoDB's storage model and its impressive capacity. MongoDB can scale out horizontally using shredding, which splits large data sets across multiple machines. It also uses a replication to ensure high availability and automatic failover, ensuring uptime during the hardware failures. MongoDB is highly efficient for storing and retrieving large volumes of semi structured and unstructured data like logs, JSON, or IoT sensor outputs. Whether it's petabytes of log data or real time analytic streams, MongoDB can handle it. Now we have explored how MongoDB stores and scales the data. It's time to understand how developers interact with the data. To walk us through MongoDB query language and how it compares the traditional SQL, I would like to hand it over to Anjali.
Now I'll walk you through MongoDB's query language. So MongoDB doesn't use SQL. Instead, it uses MQL, which is MongoDB query language. MQL is a JSON-like syntax and supports operations like match, group, sort, and project. It also supports aggregation pipelines, which let you perform multi stage transformations on your data, much like SQL subqueries and group by. No complex joins are needed. Instead, relationships are modeled via embedding or referencing. This makes querying much easier, especially for developers coming from JavaScript or full stack backgrounds. Next, let's discuss MongoDB's usability and why developers love it. MongoDB is known for its developer first design. Its document format is intuitive and matches how data is structured in code. Schema flexibility means developers can quickly adjust the model without heavy migrations. Visual tools like MongoDB Compass make it easy to query and explore data without writing code. MongoDB Atlas UI offers a user friendly dashboard for managing clusters, logs, and scaling options. This usability boosts developer productivity and reduces friction in the development lifecycle. So, now let's look at broader programming support and community engagement. MongoDB supports many languages like Java, Python, Node.js, Go, Ruby, and many more. There's also a vast global community with open source projects on GitHub, MongoDB University with free certifications, a large ecosystem of tools, documentation, and forums. This rich support network makes it easier for teams to integrate MongoDB into full stack workflows. So, next up, we'll find some additional features that make MongoDB a full scale platform. MongoDB offers several advanced features. So, they are replica sets for high availability, field level encryption for secure data handling, change streams to watch real time data changes, time series collections for IoT or analytic use, Atlas Search, a built in full text search engine, serverless functions for event driven architecture. So, together, these features position MongoDB not just as a database but as a full data platform. Now, let's summarize the key strengths that give MongoDB its competitive edge. Here are some standout advantages: schemaless structure, which means quick development and deployment, horizontally scalable via sharding, global deployments via multi region Atlas support, strong performance for read heavy or write heavy workloads, aggregation framework for analytics without needing a separate engine, integrated full text search and real time processing support. So, these features enable MongoDB to meet modern application demands that relational databases often struggle with. But to be fair, no tool is perfect. Let's now look at MongoDB's limitations. Let's look at few challenges we face when using MongoDB. The first one will be learning curve, especially for developers from SQL backgrounds. Schema chaos will also be a problem. Without structure, data consistency can suffer. High memory use, BSON and indexing may increase RAM usage. Data redundancy is also an issue. Embedding can lead to duplication. Limited ACID in older versions. Now it is improved but still not as mature as RDBMS. No native joins. Workarounds exist but not as flexible as SQL joins. Understanding these help us use MongoDB appropriately, choosing it when its strengths outweigh the limitations. Let's wrap up the presentation before we open the floor for questions. Let's look at how some top companies use MongoDB in real world applications. Adobe uses MongoDB to manage millions of user profiles in Creative Cloud. Its flexible schema helps handle varied data structures efficiently. eBay leverages MongoDB for real time analytics and user behavior tracking, enabling fast and accurate product recommendations. Bosch stores IoT sensor data from smart home and industrial devices. MongoDB handles high volume variable data perfectly. So, Barclays uses it for secure and scalable banking APIs, benefiting from MongoDB's high availability and performance. EA Games manages global player stats and in game data across platforms, ensuring a smooth experience with real time analytics. These examples show MongoDB's strength in high scale, data heavy environments across diverse industries. As we conclude, MongoDB stands out as a modern, flexible, and high performing NoSQL database. It's built to handle today's fast paced data demands, from real time processing to massive IoT data ingestion. Its schemaless design and powerful document model gives developers the freedom to build and scale applications faster. And with strong cloud support, robust tools, and growing adoption, MongoDB has become a go to database for companies across various industries. Of course, like any tool, MongoDB has its limitations, but many of its earlier drawbacks, such as limited ACID support or no native joins, are being addressed through ongoing improvements. Overall, MongoDB is ideal for projects that require scalability, agility, and performance, especially when dealing with semi structured or evolving data. Thank you all for your attention. MongoDB is a flexible and modern database that aligns with how data is used in today's fast paced environments. Whether it's real time apps, analytics, IoT, or microservices, MongoDB offers tools and performance to make it happen. I've listed the key references we used for this presentation. Thank you.